What we're going to start talking about today is data distribution. Now, distribution basically means how your data is spread out. Okay, so we've looked at box plots, and box plots is one form of being able to tell us how spread out our data is. Histograms as well. We can kind of see, which area is the highest, where they kind of clump together. And in Math 1, they also want you to know, just kind of based off your data points and outliers, how that's going to affect your data distribution. So, if your data is considered normal or symmetric, it will kind of be, this is kind of a common look to it. You might see data that has this bell-shaped curve to it. This is called a normal distribution. Now, I know my graph is not the greatest in the world, but a normal distribution, if you notice kind of our, we have this majority kind of hanging around here in the middle, and then as it gets higher or as it gets lower, our data decreases. So, for example, you might see something like heights of students. Okay, and let's say we're looking at kind of that middle to be maybe 5 foot 6 inches. Maybe, I don't know, 5 foot, let's go if you're looking at 8 inches, 6 feet, etc. Maybe 5 foot, 4 inches, maybe 5 foot 2. Okay. If we were to think about where this data is spread out, now I'm just kind of talking a majority. If we were to take everybody at High Brighton High School and just kind of, plot where everybody's height was, and our data is going to end up kind of in this normal distribution. A majority of students are going to be probably around 5'6" or so, and it's going to start teetering down. It's not a very good normal looking curve, but we can see our majority of students are going to be kind of in this range right here, 5'4" to 5'8", and as the heights increase, we don't have very few students that are, above 6 foot tall or just towards 7 foot. Same thing with 5 foot or 5'2". So that's what I'm talking about with our distribution. Your majority is kind of in the middle right there, and then as it increases, it starts to, the number of occurrences tends to decrease. That's a normal distribution. Now, normal distributions are also called symmetric. So I do want you to put another term in there as well. They like to use this term on the Math 1 exam. Okay, so another term is symmetric. It's the same thing as a normal distribution. Now, they don't have to look like this bell curve. I'm just kind of using this as a visual. I'm going to get rid of this heights example, so if you need it, pause your video. Alright, so they don't have to be, this kind of a curve, bell curve kind of looking thing. You actually get into that more in Math 3. Math 1 deals mostly with histograms. So, we might see kind of a normal distribution in a histogram too. It doesn't have to be perfect, but that's kind of a normal distribution. Our middle is the highest, that's where most of it is. And as it goes higher than that and lower than that, it's decreasing. So that again is a normal distribution if you're talking about a histogram. You can also see that in box plots too. You have the box side, the median's kind of there in the middle. It's almost symmetric to it. It looks the same on both sides. So, for an example of a box plot that's not going to be symmetric, maybe a very short little side, this is kind of spread out in here, And then you have a really long tail. That one's not symmetric. Okay. So we're not going to look as much in the visual part to it because we're not going to go through and plot all these different points. They just kind of want you to, when you look at your data, is it kind of symmetric? You know, are they all the points kind of near each other, or do you start having these outliers to it? So if you need anything from the screen, go ahead and get it. I'm going to clear it off. Okay, so at this point in mathematics, you should know what an outlier is. An outlier is a point or data entry. Probably should just put data. That is very different from other points. So, for example, if I had something like, I don't know, we were doing the number of pets in class the other day, so let's say 9, you know, somebody has 2, somebody has 0, somebody has 7, somebody has 5, somebody has 11, somebody has 6, and then somebody has 182, okay? That right there is definitely going to be an outlier to it. You're going to be able to tell in Math 1, they're not going to make them really, I mean, they're going to make them bluntly obvious in Math 1. What is your outlier? It's either going to be a really small compared to everything you have or really big. So you're going to be able to identify those outliers. Again, it's just any point that's really different from all the others. Now, what an outlier does to your data set is it's going to kind of shift. Instead of looking like a normal or symmetric graph, it's going to start shifting things around a little bit. So if you need anything from the screen, go ahead and get it. Alright, so we're going to talk about something called a skewed. We're going to have data that's either going to be skewed left, or we're going to have data that is skewed right. Oops, sorry. Skewed right, I hit the arrow. Okay, so skewness basically means that it's not going to be symmetric anymore. It's going to be kind of shifted out. So skewed left basically means you have an outlier that is below the data. Okay. So if I'm thinking more visually, let's say like a histogram. Okay. It's in a histogram that I have, I have a data point here. And then, I have data point here, data points here. And I can see in my histogram that this area over here is symmetric. That's one of my normal distribution. I have something that's way over here to the left. That's skewed left. So if you were to look at data, you might have something where, I don't know, our points are at 32, 41, 37, 42, and then we have a data point of 1. Obviously this point way down here is way to the left on our number line. So that's going to end up making our data skewed left. Whereas skewed right just means we're going to have an outlier that is above the data. So this is when you have something that's significantly higher than everything else. So if I were to think kind of to a histogram again, let's say I have some data values here. They look pretty symmetric. And then I have this point that's like way up there. Okay, that right there is definitely an outlier. And what that does is it makes my data skewed to the right. So skewed again just kind of means we have our symmetric part here, but our data is going to continue off to the right, or in this one over here, our data is going to continue off to the left because we have this data value this really far to the left, or in skewed right really far to the right. So if you need anything from the screen, go ahead and get it. I'm going to give you an example, probably pretty similar to what you're going to see on your exam. Now, your homework for this section, I pretty much wrote them just like what you're going to see. Obviously, probably not the same numbers, but kind of give you the same idea. So again, if you need anything from the screen, go ahead and get it. So they'll say something like, I don't know, somebody's age. Let's say a company has some workers. And we have, a worker that's 19, we have a worker that's 28, we have a worker that's 22, we have a worker that's, 16, we have a worker that's 24, and then we have, so these are the workers at this company, and the company decides to hire one other person, and the person they hire is 85 years old. And they'll say, what does that do to our data? Well, obviously, this number is much higher than everything else, so this is going to make our data skewed to the right. And you'll just have to be able to put that in multiple choice. So, they might have a data value that's much lower than everything else. That's going to be skewed left. If they have, in this example, a data value that's much higher, it's going to be skewed to the right. I've seen them ask questions where they'll say, let's say for this data set, this is what I have. And it'll say, these are the employees' ages at this company, 19, 28, 22, 16, 24, 85. And they say, if we removed the 85-year-old, what would that do to our data? Well, that would make our data more symmetric, or a normal distribution. They'll probably use the word symmetric in Math 1. So that's just kind of how your spread of data goes. The other thing that they want to talk about is your measures of center. So again, if you need anything from the screen, go ahead and get it. I'm going to clear it off. Okay. And they'll talk about which measure of center best represents the data. Okay. And the measures of center, when they talk about that in Math 1, they're talking about the median, and they're talking about the mean. Okay. These are both measures of center. They can kind of give you an idea of around the center or around the middle of your data set. And real quick, just kind of something to get an idea about your data. Now, your median is the middle number. So when we talked about this the other day, 50% of your data, of your data is above that number, and 50% of that data is below. And you probably remember from middle school, this is when you lined up all your numbers in sequential order from smallest to largest, and you crossed out a number on each end until you got to the middle. That was your median. Okay, you got rid of the bottom 50%, you got rid of the top 50%, and all you were left with is that very middle term. That's your median. And remember, your calculator in that 5-number summary calculates out your median, so there's no longer a use for you guys to put them in order by hand and find them. The other measure of center is your mean. This is your average. And remember, the symbol for a mean is your X bar when you're talking about your 5-number, or well, in your calculator in your 1-bar stats. And what they'll do is they'll talk about with these measures of center and how outliers affect your measures of center. When you're talking about a measure of center, I'm going to change color here a minute. An outlier, for the most part, an outlier is not affected oh, I should say, well, an outlier does not reflect. That's probably a better way to say that. Sorry. There we go. An outlier does not affect. Sorry for those of you guys that already wrote that. An outlier does not really affect your median value. Because all it's doing is it's still kind of giving you kind of that middle number to it. It just got actually canceled out that outlier when it started going through those. But when you're talking about measures of center, your mean is affected. An outlier does affect. It does not print very well. I'm sorry. I'm trying to write small and it's just not working. Come on. An outlier does affect. Okay. It is going to go through and affect your mean or this measure of center. So I know that I asked one in your homework like this. I'm just going to say, if an outlier is added to a data set, which measure of center is going to be most affected, or which measure of center is going to be the best to look at. And again, if you have an outlier in a data set, your median is going to be your best to be able to look at what your center is, because it's not affected by that outlier. It may slightly be, but not much. A mean, on the other hand, is going to be highly affected from an outlier. So, if you need anything from the screen, go ahead and get it. I'm going to clear it off real quick, and I'm just going to make up a data set. Let's say I have a data set. It has a number 1, it has a 2, it has a 2, it has a 5, it has a 6, a 7, an 8, an 8. Let's say a 9, a 10, and let's say it has a 58. Okay? So hopefully you guys would look at that and see, obviously 58 is an outlier to it. And it may say something along those lines of which measure of center best represents the data. And they'll say, like A is the mean because of this, B is the mean, and the average, right? They usually have mean and median. Occasionally they'll say something like mode or IQR or something, which is not a measure of center anyway. But let's say if I wanted to talk about the mean to this. Well, to find my mean, I would have to put my data set into my calculator, and I would have to find my x-bar. So I'm going to go through, I'm going to go into Stat, Edit, I'm going to put my data set in. Let's see, 1, 2, 2, 5, 6, 7, 8, 8, 9, 10, and 58. Okay, so with my data set, if I do my one var stats, I end up getting that my mean, goes through and find it, it says that my mean is 10.5. And it says that my median is 7. And the question wants to know which one is a better representation, or best represents my data. Well, with my data set, since I kept that outlier of 58 in there, I end up getting that my mean is 10.5. Well, that mean, remember mean is supposed to be the average of your data, that mean is bigger than all but one of my data values. So it really doesn't represent my data well at all. Whereas my mean, or my median, I'm sorry, my median is a 7. Well, I have some data values above, I have some data values below, and it kind of represents about the middle. So again, my median is going to be my best representation of center. If you eliminate that outlier, then your mean or your median, usually both of them actually are good representations. But if you have a question that deals with, with an outlier included and it says, which measure of center is going to best represent my data, it's going to be your median. Because your mean is going to be mostly affected by that outlier and oftentimes push that average, or supposed to be average, above most of your data values like it did in here, or below most of your data values, which does not measure it well.